Question 14. So we have the pilot of an aircraft wants to fly from A to D. So I'll look at the diagram A to D. The aircraft flies from A to E, so A to E, 1 degrees off course. Now, here it's useful to notice that this is telling me this is the plan view. So we're looking from above. The pilot needs to go from here to here, and it's actually going this way. The distance BC is 1 mile, so that's this distance here. Work out the distance DE. Now I can see I have a triangle inside another triangle, and often you will find that this means that these triangles will be similar, because this angle is in the smaller triangle ABC. It's also in the larger triangle, and there's a right angle triangle there, right angle there, and a right angle there. So therefore, these two triangles are similar. Now, if this was a calculator paper, I could have used trigonometry to find this, because I have the angle, I have the adjacent side, and I'm finding the opposite side. But on a non-calculator paper, we can't do that, and we need to use similar triangles. So here we've got 60 miles, and the longer length here is 210. So you need to find the multiplier that takes you from 60 to 210, and then multiply it to 1, and that will give you this length here for question A. Now, question B says, how should the aircraft have turned at C to fly towards D? So how should it have turned from there to fly towards D? So tick a box. 1 degrees clockwise, between 1 and 2 degrees clockwise, 2 degrees clockwise, and more than 2 degrees clockwise. Now, if the plane is here, it's going this way. Now, if it did turn 1 degrees, what we would have is, we would have an angle like that, and it will start moving in that direction like that, parallel to the AD. So if that's 1 degree, that won't do. Okay, so you can see that how if it was to turn 1 degree clockwise, it doesn't work. They end up somewhere there. Let's check 2 degrees. So if I was to have another 1 degree, so that makes it 2, the pilot will be flying this way. Now this, I can't assume that I've drawn this accurately. Okay, here it's telling me it's not drawn accurately as well. But let's think about what we have here. So we've got 1 degrees there, 1 degrees there. This angle here must be 89. Okay, so this angle here must be 89 degrees. This angle is also 89 degrees. Okay, and now if you look at the angle here, so if we look at the angle here, the length 1 mile, and then the angle 90, and I have the same thing on that side. I have 89 degrees, the length 1 mile, and then the 90 degrees there. What I have is angle, side, and then angle, and here I've got angle, side, and angle. Therefore this triangle and this triangle would be congruent, and therefore this length here would be 60. So it would cross here 60 miles from B towards D. Okay, so if this is 150, it will come here about 60 miles, and then there'll be another 90 miles left to get to D. So that was a 2 degree turn. So the plane was going this way. If we were to turn 1 degree is there, 2 degrees is there. Okay, so now we can see that it needs to be more than 1 to go somewhere here, and it needs to be less than 2 to go somewhere here. So that's how you decide where it will be. Question 16 is a rearranging question. Here, it's useful to know what steps you will do before you start. Okay, so the first thing we can say is we need to multiply the right hand side and the left hand side by x take away 5. That will mean the fraction will not be there anymore, and we will have x take away 5 times y here. But the x take away 5, it would have to come as a bracket, and the y will multiply to the x and to the negative 5. Then I would multiply the brackets on this side, and then I would collect the terms in x. This take away 3x will come on this side, and here I would have yx. So the terms in x will come on one side, and everything else goes on the other side. Now, as our terms in x, one of them would be with a coefficient, the coefficient would be a number for one of them, and the other one would have yx. So you wouldn't be able to simplify them, and that's when you know you need to factorize. So when you factorize, you'll be writing a multiplication that gives you from that says x times something is equal to something on this side, and the x will be only in one position. And then when you have that, you can divide by whatever the bracket is after you factorized, and then you would have x as your subject. So question 17 says the diagram shows a rectangle inside a semicircle. So a rectangle inside a semicircle. The rectangle has dimensions 16 centimeters by 6 centimeters. So this is 6 and this is 16. Okay, and remember rectangles have 90-degree angles here. All of this information might be useful to us. Work out the shaded area. Okay, so work out the shaded area. Give your answer in terms of pi. Well, this is a semicircle. So to find the area of a semicircle, I do need to know the radius here. Now I can see that from the center, the radius is actually the length that goes like that. That might be useful to me because that's all of that is in the rectangle. So if I was to say this is the center, the line that takes me from here to there, that is a radius. Okay, and I could have said the same that way as well. I'm not saying up to here because I wouldn't know what the length here is. That's too tricky for us with the information given. But this works for us. So this length here is 6. This is 6 centimeters. Now I can see that it will be symmetrical here. Okay, so this must be 8. Okay, because 8 and 8 makes 16. And remember we said that this is a right angle. Now if this is 8 and that's 4, then we use Pythagoras theorem to find this. Not 4, this is 6, isn't it? 8 and 6. So 8 squared add 6 squared. Square root of that will give me the radius. When I have the radius, I know pi r squared gives me the area of a full circle. I would half that. But I would still need to write in terms of pi, which means use your algebra skills and keep it in terms of pi. And then I need to take away the area of the rectangle, which is going to be 16 times 6. Okay, and then all of that needs to be simplified in terms of pi. Now question 18 is two straight lines are shown. B is the midpoint of AC, so B is the midpoint of AC. TB to BS is 2 to 3, so TB to BS is 2 to 3. Work out the coordinates of T. Okay, now to find the coordinates of B will be quite easy, and that will give you some marks. You would just add the x coordinates here and divide them by 2. That will give you the x coordinate there. Add the y coordinates here divided by 2. That will give you the y coordinates there. Now we could just be looking at this diagram with these two lines and these dots defined here. Now what we've got is we've got it defined in terms of x and y. So the relative position to the x-axis and the y-axis has been given to us. Okay, and the x and y-axis are at right angles. Okay, so it's very useful to think of maybe right angle triangles that go parallel to the x-axis and parallel to the y-axis. That might help us. So what I mean by that is after you found the midpoint here, which is B, think about right angle triangles like this and a right angle triangle like that. Now what you can do is, if you know the coordinates of B, so let's just say what it is actually. The coordinates of B, 15 out of 23, the x coordinate of B, 15 out of 23 is 38, and half of 38 is 19. So the x coordinate of B is 19. Okay, so 19. So it would have come up to 19 here, and we need to get up to 31. So you can find this length. 19 to 31 is 12. So this would be 12. Okay. Here with the T, we don't have the information yet, but we know that this 12 is this part here. So think about how this would need to change to give us this length here. Okay, because these are similar triangles here. Okay, so that's how you think about it. So this 12 relates to this 3. Okay, so think about how to get from 3 to 2, and that will be the same for, that will take you to 12 to whatever this length here is. Okay, you can do the same for the y coordinate as well. So 6 add 12 would have been 18. Half of that is 9. So the y value here is 9. So we went from 3 up to 9. So this length here is 6. Okay, so this length is 6 units long. And then you would multiply 6 by the same scale factor to get you there, or you might divide. Okay, so think about how that would work. Okay, question 19 says a cuboid has dimensions x centimeters, and y centimeters. So x, and y. X is increased by 10%. So I think we have to assume that this x and that x, both of them are increased by 10%. Y is decreased by 20%. Work out and describe the percentage change in the volume of the cuboid. Now, to find the volume of this cuboid, we would just multiply y by x by x. So x squared y. If I increase x by 10%, I'm multiplying it by 1.1, and I'm multiplying this by 1.1. So we carry on the multiplication. We said y times x times 1.1 times 1.1. And then y is decreased by 20% times by 0.8, because that's the multiplier for decreasing by 20%. Now, that might be difficult for us to work out. So I'm going to ignore the volume part, because it's only telling me work out and describe the percentage change in the volume of the cuboid. Okay, so the volume is going to be x squared y, and then how has that changed? So it's changed by multiplying by 1.1, and then multiplying by 1.1 again, and then multiplying by 0.8. So they're the only numbers I'm going to be looking at. So I'm going to say 1.1 times 1.1 times 0.8. Okay, if I was to multiply this all out, okay, if I get a number more than 1, that means it's an increase by a certain percentage. If it's less than 1, like this 0.8, then it will be a decrease. Okay, so this is not easy to work out. Okay, it's easier to do it with fractions. So here you can say 11 over 10, 11 over 10. You can use 8 over 10, or you can use 4 over 5. Okay, so use fractions, multiply them, and then change that back to a percentage, and then work out whether or not it's a percentage increase or a decrease. So you would have to say it's an increase by a certain percentage or a decrease by a certain percentage. Okay, question 21 says expand and simplify, and they've given us 3 brackets like this. Now here what you need to do is work with 2 of them first. So just leave that one, okay, in your expression, but multiply this bit out. Okay, so when you multiply this bit out and you simplify the x terms, you will have 3 terms here. Okay, so you'll have a bracket of 3 terms, okay, multiplying by a bracket 3x plus 7. And then the 3x multiplies to all the 3 terms, and the 7 multiplies to all the 3 terms, and then you simplify all of that, and that will give you your answer. Okay, question 22 says, write this expression, which has some surds, in the form a root 2, where a is an integer. Don't let this put you off, okay? You can see that what it means is you need to deal with this in such a way that you simplify it, and then eventually it will look like that, okay? So that's what we're looking for. With surds, the first thing we should look for is, can we simplify root 2? We can't, so we leave that. Root 18 does simplify, because 18 is 9 times 2. Root 50 does simplify as well, because that's 25 times 2. Do those simplifications first. Then we know that we've got fractions here. When we've got fractions, we need to make sure that we have, and we're subtracting or adding them, we need to make sure that the denominators are all the same before we can do that. This one doesn't simplify. There is another thing that we need to do. You can see that we might need to rationalize the denominator as well. I would prefer to do that at the end, okay, after I've made one fraction, okay, but you might want to do that first. Doesn't matter which way around you do it, but I prefer to do it at the end. So this fraction here, it would be 12 over 3 root 2, because 18 is 9 times 2, okay. This would be 2 times 5, which is 10 root 2, okay. Now this is not a fraction at the moment, but you can say that 10 root 2 over 1 would be the same as 10 root 2. Okay, so use 10 root 2 over 1 and then make a common denominator, add them up, and then rationalize the denominator. And then once you've simplified it, it should look something like this, where a is an integer. Okay, question 23a. The graph of y cosine x is shown for the domain 0 to 360. On the grid, sketch the graph of y cosine x, take away 1 for 0 to 360. Now, what you have here is, this is like a function, okay? And we sort of have the same function here. We need to do sine x. So we need to take x and we need to apply the sine to it. And then we get this graph, okay, when we take these values of x. Now, here we are going to do the same thing, but then once I've got the answer of the sine x, I take away 1. Okay, so here we would have done sine of 0, which is 0, and that's what I have here. But here, to get my y value, I then need to take away 1. So from here, I would actually go down here. Same here. If I did sine 90, sine 90 is equal to 1. So here, my y value would be 1, and we plot it here. But here, I do need to do sine 90 because the x value is 90 here. So sine 90 is 1, okay, but the y value is not 1. I still need to take away 1, and that takes me to 0. So this point would have come here, that point would have come here. Just think about where each of these points will come, and then draw your sketch. In 23b, we have the graph of y cosine x is shown on the grid for 0 to 360. On this grid, sketch the graph of y equals negative sine x for 0 to 360. Now, here we have to think about this again. Okay, so the same idea. We've got the function sine being applied to x, and then we take the negative of that. Okay, so if I do sine 0, that gives me 0, and then I apply negative to that, well, it's still 0. So this point actually stays here. Let's look at what happens when we do sine 90. So sine 90 is 1, and so sine 90 takes me to 1, but then I need to do negative of that, so then it will be negative 1. So this point stayed there. This point actually came here, okay? And think about what happens to these points, and then you will have to draw your sketch from there, okay? Okay, question 23. It's just saying to us, on this grid, sketch the graph of y equals tan x for 0 to 360. That's a graph that you have to remember what it looks like. It's not a curve like the sine and cosine curves. It's a little bit different, okay? There are some asymptotes and things like that you have to just remember how that looks and where we have the asymptotes, and draw it from that. Okay, question 24. A bag contains n beads. One bead is black and the rest are white. Okay, 2 beads are taken from the bag at random. Okay, so 2 beads are taken from the bag at random. That means without replacement. Show that the probability that both beads are white is n take away 2 over n. Now, when the first bead was taken, there were n beads in the bag. Okay, so it would have been out of n. Okay, so it's out of n. But what situation were we looking for? Well, show that the probability that both beads are white. We wanted to see how the number of white over n. The number of white beads would have been n take away 1 because they said 1 bead is black. Okay, so we would have n take away 1 here. When the second bead was taken, now the denominator would be n take away 1 because 1 bead has already been taken. And the numerator must be n take away 2 because one of the white beads is gone, 1 bead is black, and there's n take away 2 white beads left. Okay, and then you would multiply the two fractions. Okay, so you would take this fraction and you multiply it to the other fraction, and then you need to show that it simplifies to that. Question 24b. The probability that both beads are white is greater than 0.9. Work out the least possible value of n. Now, this is a very big part of GCSE Maths. Okay, we need to make equations and inequalities from information like this. So here we've got the probability that both beads are white. I'm just boxing that, and then we've got is greater than. I'm doing a different color, so is greater than, and then we've got 0.9 on this side. Okay, that is an inequality. Okay, so whatever that is, then I have to say is greater than 0.9. So I make an inequality and I solve it, and then I interpret it for this question, work out the least possible value of n. Okay, so here what we're going to have is, I know that the probability that both beads are white is here. So I may have got this wrong, but I can just use that here. Okay, so I'm going to say n take away 2 over n is greater than, and then we have 0.9. Okay, so notice how there's this part here is greater than, that's the symbol, and 0.9 goes there. Okay, sometimes it will be the probability of something is that. When it says that, then instead of a greater than symbol, you would use an equal sign. Okay, so that's a very, very big part of GCSE Maths, and it comes up in all the papers, and it comes up quite a few times in the papers. So notice how you need to form inequalities or equations and then solve them. Here we're going to have to solve this inequality, and then once we've solved it, we have to interpret what this question is asking us, work out the least possible value of n, and then give a number there. Okay, question 25. ABCD is a parallelogram. So ABCD is a parallelogram. ABE is a straight line, and ABBE is 3 to 2. So ABE is a straight line, and this is 3 to 2. BC and ED intersect at F. So BC and ED intersect at F. AB is equal to A, and AD is equal to B. Okay, so vector directions are important. Work out ED in terms of A and B, give your answer in its simplest form. So I need to get from E to D. So that's one way we can go. We could go this way, and these ways don't really help us because there's no vectors defined in this way. But here we do. Okay, we do have some vectors here. Now, if this is 3 parts to 2 parts, then this going from B to E must be 2/3 of A, but that's going in this direction. So we need to have negative 2/3 of A, then we've got A, or 3/3 of A, add B. Okay, so, and then you have to simplify that to get your answer here. Okay, so question 25b, we have deduce EF in terms of AB. So EF is here in terms of AB. So what we have is a parallelogram. So the vector BC would be B, but we don't know how far F is from B. So because we haven't been told that, but we can maybe work it out. So what we have is, we can see that we've got a triangle here, and then another triangle inside it. Often you will find that this is similar triangles here. So what we have is a parallelogram. So these lines are parallel. Therefore, this angle and this angle will be equal. These are corresponding angles. So I can mark them here. So these two angles are equal. And then if I mark the angle BEF, this angle is in the triangle BEF, and it's also in the triangle AED. Okay, so there's two angles that are the same in my two triangles. Therefore, these two triangles are similar. So there's some scale factor that will take me from this length to the length AE. And I know some quantitative relationship between these two because I've been given that AB to BE is 3 to 2. So this is 3 to 2. So if this length, suppose this length was 2, the length A to E would be 5. Okay, so what multiplication takes you from 2 to 5? That will be the same multiplication that takes you from the length BE to the length AD. Okay, so the vector BF would be some multiple of B, but we can see it's going to be smaller than that because BC is equal to AD, which is B. So the scale factor you can find by saying, okay, 2 times a number gives me 5, which is the longer length, and then use that to divide B by that, okay, and then that will give you the vector from B to F. And then to find E to F, we can take this path this way. Okay, so the vector E to B, we already have that from 25A. And then we're going to add to that BF, which I just discussed.